The second reaction that conjugated systems undergo is the bromination. So the second one is the reaction with Br2. It's going to be a reaction with X2. It's going to be either a bromination or a chlorination, any one of those. The reaction is called halogenation of dienes. And with the halogenation in particular, we're gonna always start with symmetrical dienes. So we're gonna always start with symmetrical dienes. Okay. The rule is going to be the same in there. It's either like you are doing all the products or you're doing the kinetic, depending on the temperature. If the temperature is low, or you are doing the thermodynamic if the temperature is high. So let's have an example over here. We're starting with this symmetrical diene, and we are reacting it with the bromine. Bromine or chlorine, they go by the same mechanism in there. Here, I want you to list all the possible products. So in this case, you are going to write down the 1, 2 plus the 1, 4 addition, all of them, okay, including stereochemistry. Let's start by numbering our conjugated system. So that is going to be my conjugated system over here. And I'm going to start from this carbon. It really doesn't matter from where you start. So I'm going to start because it's a symmetrical one. So this is going to be 1, 2, 3, and 4. You cannot start numbering from here. Because if you start numbering from here, this is 1, 2, 3 is not conjugated. 3 is an sp3 hybridization. Your conjugated system is here, and we're going to number only our conjugated system. This is why I'm forcing to start either from here or from here. It's the same. So now I'm going to start by reacting this with a bromine. Remember in organic 1 when we did a reaction of alkenes with a bromine and we created a cyclic brominium ion? This is exactly the same. So bromine is nonpolar. However, because of the electronegativity of the bromine, you are going to create a fake dipole, and that dipole means that one bromine is going to take more electrons than the other and create a plus charge on the other bromine. This is your electrophile that is going to start the reaction with the nucleophile. So you have your alkene as a nucleophile and your bromine as an electrophile. So we said over here that the double bond is going to open up. And when the double bond opens up, this is going to be your nucleophile. It's going to come and pick the bromine, which is the electrophile. And then the lone pairs on the bromine are going to close down the cycle. Here you have two options. The bromine can attack because the double bond is planar. So the bromine can attack either from the top to make the cyclic brominium ion. This way, your ethyl is going to be pushed to the back. Plus, your bromine or cyclic brominium ion is going to attack from the back, and that is going to push the ethyl group to the front. Okay, don't forget your double bond between carbons 3 and 4. Please write it down. Now, the difference between bromination, chlorination, or the addition of HX. With the addition of HX, I created immediately my allylic carbocation, and I could do resonance immediately with the allylic carbocation. But here, no, I don't have an allylic carbocation in there. So now I'm going to go ahead and proceed to the next step of the reaction. Since I'm showing all possible products, I'm going to start with the 1,2 addition in there. Don't forget that you have a bromine in the solution. So you have your Br in the solution in there. And the Br is going to attack. So the Br minus, it's going to come and attack. And that Br minus, when it attacks, you are going to end up getting either the 1,2 or the 1,4 addition. The attack is going to be based on the mechanism that I am writing over here. So the bromine can either come over here and attack carbon number 2, open the bond. This is carbon 1, this is carbon number 2, so that you can have a 1,2 addition. So the bromine over here can come and attack from the back of the cycle. Since the cycle over here is in front, the bromine needs to attack from the back. It cannot attack from the same side because of the size of the bromine. So in this case, I would end up forming my bromine over here, okay, and then my bromine at the back. You need to consider the stereochemistry in there. This is going to be a trans addition, and that is going to push the ethyl group to be at the back in there. The bromine here is going to retain the same stereochemistry as the cyclic brominium ion. So this bond is going to open up or break, and the bromine is going to add to this carbon. So over here, it's as if I did a 1,2 addition. So this is a carbon number 1, this is carbon number 2. So this is going to be a 1,2 addition. Don't forget your double bond in there. So you do have a double bond between carbons 3 and 4. So this is carbon 3 and this is carbon number 4. Keep that. So it's either a bromine attacking carbon number 2, opening the bond for this stereoisomer, or the bromine attacking from the front of this carbon. We're still in the 1,2 addition and opening this bond. So you are going to end up getting the second isomer in there. Here you go, where the bromine is going to be at the back, the ethyl is going to be in front, and then the bromine attacked from the front over here. It's still a trans addition to the bromine. Both the bromines need to show that they are trans with respect to each other. This is for the 1,2 addition. Okay, so you have your 1,2 addition in there. And these two are going to be a pair of enantiomers because they differ in 2 chiral centers. This is a chiral center here, this is a chiral center in there, and they both differ in 2 chiral centers, so this is why they are pair of enantiomers. Now the 1,4 addition. So here I had the 1,2 addition, now I'm going to have the 1,4 addition. For the 1,4 addition, we do have Br minus in the solution still. And the bromine has 2 options in this case. The bromine can either come and attack this carbon over here. Let's number our carbons. So this is going to be carbon 1, 2. We said this is going to be 3. This is going to be 4. This is going to be 1, 2, 3, and 4 over here. Since it's a 1,4 addition, we already added the bromine. So now we're going to add the second bromine on carbon number 4. If you do this, then the double bond here is going to be moved between 2 and 3. And then the bond between the carbon and the bromine here is going to be broken. This is how it's going to be formed. This is how the addition is going to be. This is very different from the HX addition. In the HX, we created the carbocation. Here, we cannot because of the cyclic brominium ion. So this is why the Br minus needs to attack carbon number 4. You do resonance with the double bond and open up the cycle. Now, because this carbon over here is going to be planar, the 2 stereoisomers, where the bromine attacks from the top and the bromine attacks from the back in there. So let's go ahead and consider one and then write the other. So let's say, for example, if the bromine is attacking from the top over here, that is going to push the ethyl to the back, and then it's going to open the bond, So here you go. So open the bond, make a double bond between 2 and 3, and then break this cycle. So my first stereoisomer is going to be a bromine here to the back, my ethyl group to the front. This is carbon number 1 addition in there. My double bonds are between carbons 2 and 3. And then I do have, we said that the bromine here is attacking from the top. That is going to push the ethyl to the back. Plus, there's also a possibility, the same isomer here, bromine, can attack from the back. So if bromine attacks from the back, that is going to push the ethyl to be in front. The double bond is going to be between carbons 2 and 3 because this double bond still is going to move between carbons 2 and 3. And this sigma bond over here is going to be broken, and the bromine is going to be at the back. Here you go. And that is going to be in front. Which one is more stable? We always seek to form the trans isomer because the trans isomer, the trans addition of the bromine, is more stable than the cis addition of the bromine. This is why in most of the books this one is not mentioned in there, because it's not very stable, because you have two bulky halogens, they are on the same side. So if you want, you can neglect this isomer in here. If you want to write it down, it's not a big deal. Plus, the bromine now is going to come and attack the second isomer in there. And it's going to do exactly the same. So it's going to come, and the attack is always going to be on carbon number 4 because we are doing the 1,4 addition. So now this bromine is going to come and attack the carbon over here. And again, it's going to attack it from the top or from the back. And you have the option to ignore the cis isomer or the cis addition of the bromine in there. You have your double bond in there, and then the cycle is going to open up. So you are going to end up having our second set of the products in there, where the bromine attacks from the back. This is more stable because this is going to produce the trans in there. And that is going to push this bromine on this carbon and the ethyl on the other. Okay, notice that both the bromines and the ethyl groups, they are trans with respect to each other. Plus, the bromine can be cis. The ethyl is going to be at the back. Over here, here you go. So this is your alkene in there. And you get all of those to be the 1,4 addition products. As I said, these two have bromines that are cis with respect to each other. So let me circle those over here. These are not preferred to form. So these are not preferred to form. You can either write them down or you can go ahead and neglect them. And in this case, I believe in my answers and the problem in the extra problems, I am not showing the cis addition. I'm only showing the trans addition because this one is more stable. So assuming that we neglect the cis addition there, we get two products for each of the 1,2 addition and the 1,4 addition.